Good evening. So, yeah. Good evening. Louder. Okay. Good evening and welcome. It's exciting to see everyone here today. You may want to take a seat. I have more than a moment of remarks, Martin. But I'm Stacy Bent, Senior Associate Dean for Faculty Affairs at Stanford School of Engineering. Thank you very much for joining us tonight. Not only do we have a full house here in NVIDIA Auditorium, but we are webcasting live on Facebook to thousands of alumni, students, and friends around the world. We are here tonight to honor Martin Fisher, co-founder of Kickstart International, a nonprofit that has lifted more than 1 million Africans out of poverty. The Stanford Engineering Heroes program, now in its 5th year, recognizes the achievements of Stanford engineers who have profoundly advanced the course of human, social, and economic progress through engineering. Our heroes represent the best of the very best. They personify the Stanford Engineering mission to seek solutions to important global problems and enrich humanity by using engineering principles, techniques, and systems. Their life's work demonstrates a commitment to not only advancing technology, but also changing the world for the better. And they embody leadership qualities that inspire future generations of engineers to apply their education to have a positive global impact. Along with Martin, this year's inductees include Netflix co-founder Reed Hastings and Perry McCarty, the Silas H. Palmer Professor Emeritus in Stanford Engineering's Department of Civil and Environmental Engineering, and one of the world's foremost authorities on microbial processes used in the treatment of water, wastes, and hazardous chemicals in the environment. And we're very pleased to have Professor McCarty here with us today as well. They join a distinguished group that includes such luminaries as physicist and astronaut Sally Ride, former U.S. Secretary of Defense and Stanford faculty member William J. Perry, and Nobel Prize-winning economist Kenneth Arrow. Martin Fisher is co-founder of Kickstart International, and given the scale of impact that he and this organization have had, it is no surprise that he joins this distinguished list. Martin got his PhD here at Stanford in theoretical and applied mechanics in 1985. His advisor was the late George Herman from the Mechanical Engineering Department. While completing his degree, he traveled to Peru, where he first encountered extreme poverty. As an engineer, he wondered how technology could help, and in 1985, he went to Kenya on a Fulbright scholarship to find out. He stayed for 17 years. He built low-cost schools, established a large water program, trained youth, and designed pit latrines for refugee camps. He also met Nick Moon, a carpenter and builder, and together they realized that the biggest way they could help Africa's poor was to provide tools that would enable them to earn money on their own. In 1991, they co-founded a pioneering social enterprise to design and market low-cost tools that can be used by the poor to establish highly profitable businesses. They also recognized that millions of African farmers would be financially better off if they made the transition from rain-fed farming to year-round irrigated agriculture. So Kickstart designed and started mass marketing low-cost irrigation pumps. Kickstart is an example of engineering's singular ability to solve social ills through technology and innovation. I can think of no better way to recognize this than to quote 2 of Martin's friends and former Stanford classmates. Craig Milroy, a senior lecturer in the Mechanical Engineering Department at Stanford, was a classmate of Martin's and recalls his extraordinary ability to see things that others don't, to explore things from a unique perspective. I get creative, Martin once told him, by looking at things upside down. Steve Eglash, executive director of a number of programs here at Stanford, once lived with Martin in Menlo Park while they were both working on their Stanford degrees. He calls Martin remarkable and admirable because he is one of the most passionate humanitarians I know, and he is also one of the most pragmatic realists I know. Tonight, we celebrate Martin as one of Stanford Engineering's heroes and honor him with this token of our appreciation. We'll let you come get it later. It is a duplicate of a plaque that's going to hang on our heroes wall just down the hall. Congratulations, Martin. I'm pleased to introduce Martin up to the podium.
Great. Well, thank you for that very kind introduction, Stacy. And thank you and welcome everybody for being here, including family and friends. It's great to be back at Stanford. Certainly honored to be considered a hero. Not sure I deserve that, but honored anyway. And I want to tell you a bit about my journey, the many learnings that we've had along the way, and a little bit about how engineering really can help millions of people to get out of poverty. So I grew up in an academic family with my father and my brother, academics, sitting here in the front row. And you almost needed a PhD in physics to qualify for the family. So being a dutiful son, I graduated from Cornell and came out to Stanford to get my PhD. And I did get it in a physics lab, although actually I was a mechanical engineer in a theoretical and applied mechanics. But in many ways, I realized the more education I got, the less I was actually qualified to do. And so 2/3 the way through my PhD, I realized I was very qualified to try to teach somewhere. Or I could have gone and worked for big oil doing exploration. Or I could have done military research. And none of that was very exciting to me. And so I was kind of wondering what I was going to do with my life. And then my brother, Daniel, invited me to go down to Peru with some friends of his to go trekking. And I told my advisor I was going to write my thesis that summer, but in fact I went down to Peru. I later told him I was going to write my thesis in the winter and went skiing, but that's another story. But anyway, going down to Peru was really for me the first time that I sort of came face to face with real poverty. And started wondering, you know, is there anything that can be done with poverty and the engineering skills, what little I may have had. And I decided, well, let me go back to Peru and take a break from academics, you know, probably for 10 months, a year, and then probably go back to an academic job. And so I thought I'd apply for a Fulbright fellowship. And so I got ready to apply, and I was going through my interviews here on campus, and they told me, this was 2 days before the final applications were due, you're not going to Peru. And I'm like, why? And they said, you don't speak Spanish. And I'm like, shoot, you're right. And I literally then looked through the catalog, this was in the days before the internet, and I realized that they speak English in Kenya. And I flipped my application to go to Kenya, and got lucky enough to get a Fulbright, and went down to Kenya. This is back in 1985, and yes, I was young and good looking once too, so. And I went to Kenya, which is, of course, in sub-Saharan Africa, and really, which is one of the world's very, very poorest places, right? You've got a population of about 1.1 billion people living there. Almost half of them live below the poverty line. On any given day, 30% of them don't have enough to eat, are hungry. 35% of those under 5 are stunted, and we know what happens if you're stunted under 5. You never really mature into a full, capable human being. The population is growing very, very rapidly. The best demographers say that we're going to have 2.2 billion people in Africa by 2050, and we're going to have 4 billion people in Africa by 2100. Now, this is assuming, these assumptions are assuming that every woman and girl alive today only has 2 children. And the reason for this is because you've got a huge number of youngsters and very few old people. Right? So you've got a population that looks like this now. You can imagine if that fills in. So you got 3 billion people extra in Africa by 2100, only 1 billion more people in the rest of the world. But clearly, the challenges in Africa are absolutely huge. I always say that, you know, we'll be able to walk across the Mediterranean Sea on rubber dinghies at that time. You won't need to actually get your own boat. There'll be so many people coming to Europe. So already you've got a continent that can't feed itself and is growing very rapidly. So something has to be done. So anyway, I didn't really know what, but I went down on my Fulbright Fellowship to look at poverty and technology. I thought that I'd jump right into the appropriate technology movement, which was a movement that started in the 80s or 70s when Schumacher wrote a book, Small is Beautiful. Everybody got very excited about local small-scale technology to help the poor. And I thought I'd jump right into that. But in 1985, it turned out that was old news. Nobody cared about that anymore, and nobody was working on technology for poverty alleviation. Many lessons that had not been learned about why it didn't work. But nonetheless, that's what happened. And so I did find a small group at a place called ActionAid, which is a nonprofit similar to Save the Children. And I met a man there called Nick Moon. And Nick was a carpenter and an entrepreneur who was now building low-cost primary schools. And I joined him as a volunteer to begin with for a couple of years and then later as a job. And at ActionAid, I did a number of things, as you've heard a little bit about, but I established what became one of the very largest rural water programs in Kenya, where we'd go into rural communities, we'd dig wells, put in pumps, we build water catchments. That was a very big program that I ran there. I helped youth groups and women's groups to get into employment, working as groups. I set up a couple rural workshops where we mass-produced farm equipment, especially ox-drawn plows and harrows and ox carts, and we gave them away to farmers. But so often with my academic training, I looked back on it and I realized very often we were actually not having much impact and sometimes actually doing more damage than good. Putting a nice clean water point in a village, it turns out doesn't actually do a whole lot for health by itself, because by the time the water gets home, it's dirty. But much more than that is we would come in, we would put these in place, we would train the community to look after them, but by the time it broke down, of course, all that training had been forgotten. And Africa is littered with about 200,000, 300,000 broken down community water points. We continue to put them in. All the ones I put in back in the 80s, 90s are gone. So giving farm equipment away sounds like a nice idea, but of course, the farmers maybe don't appreciate it that much because it might not have been what they wanted in the beginning, but much worse than that, there's a guy down the road producing farm equipment, and of course we put him out of business. And then when the project runs out, there's no farm equipment locally. Building low-cost schools is nice, but it's not actually the highest priority to get the building. You don't have any teachers. And youth groups and women's groups, great to set them up in businesses, but the truth is it's very difficult to run a business as a group. Even running a business with two people is difficult. And so we would hold their hands and everything, and it would work. But the minute we let go, it would fall apart. And meanwhile, there's an entrepreneur down the road who would have liked to start the business, and we were keeping them out of the business. So learned a lot about what doesn't work and a few things about what do work. But individual family owned is best. Sell products, don't give them away, because it's fairer, cheaper, and it's more sustainable. I became, when I went over, probably a socialist, thinking I'm going to go and help. And I became sort of a small C capitalist, realizing that it's actually the jobs and other things that are going to help more. But the other thing you learn in development is nothing is scaled. There's all sorts of islands of success, small things that work on a small scale, but nothing is really having an impact on a large scale in development. So the biggest lesson I learned, though, was something when I really asked the question is, what do the poor want and need? What do they actually want and need? Well, it's a long list. Not that long, but they need food, obviously, staples and process. They need farm inputs and tools. They need clothing and shelter, education, healthcare, cooking fuel, lighting, transport, communication, things like soap and cosmetics, water and sanitation. It's not a very long list, but these are the things that people want just to live in their lives. But the number one need of anyone who's poor anywhere in the world is really only one thing, and that is a way to make more money. Because all of these things on the list above cost money. Bottom line is, if you have a way to make money, guess what? You can get all these things. If you don't, you never will. You never get out of poverty, right? So that's great. In fact, the world's most urgent problem is the fact that something like 2.5 billion people in the world, 500 million families, need a way to make a whole lot more money. And it's not that they're making no money. They're making some money, but they're just not making it enough. And so people think that the formal private sector is going to help solve this problem by creating big companies that create jobs. And it's a nice idea, but if you look in Kenya, 7% of the labor force works in the formal private sector. Tanzania, it's 3.5%. Sudan, it's 1.5%. But even in India, which we think of as a developed country, it's only 10% who are working in the formal private sector. So it's great that we start big businesses, but that's not actually solving the problem for unemployment. So what is solving the problem? Well, it's actually the people who are solving the problem themselves. They need money, they're entrepreneurial, they have to be just to survive, and they're hardworking. So what do? Well, they grow crops if they're farmers, and they sell the crops because they need the money more than they need the food, right? And then later on, of course, they have to buy back food. And they all plant at the same time, they all grow at the same time, they sell into the same market. Of course, they don't make a lot of money when they do that, but they make a little bit. Or they join the informal sector. Now, the informal sector, which is where most people work, is made up primarily of people doing petty trade. People sitting on the side of the road, buying and selling the same things. I'm doing the same, you're doing the same, we're all doing the same. Our margins are tiny, we're making a little bit of money, but we're not making a lot. Or if it's not petty trade, there's a list of about 10 other businesses that people do. Metalwork, carpentry, tailoring, food preparation. There's a list of about 10, and that's 99% of the informal sector. Everybody doing the same thing, competing with each other, making very small margins, and staying in poverty. Surviving, yes, because they make a little bit, but not escaping poverty. So if you look at that from a business point of view, what's the problem? Well, the problem is they're all in the wrong business, right? Because they're all doing the same thing. And it's kind of not surprising. Hey, it's even hard for us, the best educated people in the world, to come up with a new business idea, right? Obviously much harder for the target audience we're talking about here. And even if they can come up with a new business idea, they can't access the tools and equipment they need to make that business viable. That's what we realize. That those tools and equipment that are not available, certainly not where they are, and very often not anywhere in the world. So they need help identifying those businesses and accessing the right technologies for those businesses. So Nick and I at ActionAid, we told our bosses this is what had to happen and that we needed to do this kind of work, designing technology for people to start businesses. Now, they didn't like that idea very much, and they asked us to leave. In fact, they kind of charged me with gross insubordination. I had to look it up in the dictionary. And I had to leave ActionAid, as did Nick. But we managed to convince them to let us stay for 6 months. And in that time, we established what was back then a nonprofit. Nowadays, you might call it a social enterprise. 1991, we called it APROTECH, Appropriate Technologies for Enterprise Creation. In 2003, we changed the name to Kickstart. And yes, Kickstarter did steal their name from us. Literally, I knew their founders, and I didn't do anything about it at the time because I never thought they would go very far. That's why I'm not an investor. Anyway, that's what we were called. And our mission is very simple: lift millions of people out of poverty by enabling them to make a lot more money and do it quickly, cost-effectively, sustainably. And so we set off and we got a bit of a grant from the British government. And that was a grant to basically, it was a matching grant. They gave us some money to get going. And we matched it with our salaries by basically volunteering in the beginning, so at least we had a little bit of money to spend. And we rented a space in a slum just outside Nairobi and built a workshop there, set up a workshop, very primitive workshop, which even today is a pretty primitive workshop. And we said, we're going to go out and do technologies for development. And just to quickly review, but what kind of technologies and tools can lift people out of poverty, right? What are they? Well, for us, labor-saving technologies and time-saving technologies are pretty nice things. We pay a lot of money for them, right? But for a poor person, they're not going to pay much for a labor or time-saving technology because there's a low opportunity cost. You know, they have a lot of time and labor, so they might not be interested in our time and labor-saving technologies. A money-saving device is nice if you have any money to save. Well, if you're poor, you don't have a lot of money to save, right? So you're not going to spend much on a money-saving technology, but you might spend a bit on it. So something like a solar lantern, which saves money from kerosene, yeah, if it's cheap enough, you'll buy it, and sure enough, the prices are now cheap enough, people are buying them, but you're not going to spend a lot on it. But a money-making technology, you're going to spend a lot on, right? Because that's your number one need. But still, it's got to be affordable, and it has to have a very profitable business model because you don't have access to credit and you don't have a lot of money. And we always talk about farm time, that it should be able to recover the investment in 3 to 9 months because people are used to putting their money in the ground in the farm for that kind of length of time and then getting their investment back. But much longer than that, and it's unlikely people are going to invest. So that sounds good. And why is technology so critical for powering businesses? Why has it been throughout history? Well, only with technology, of course, can you get lower cost, better quality, and brand new products and services, right? And it's something which is obvious but easily forgotten. And so this is why technology is so important. And you need high quality technology, right? So you need quality design and engineering. So often when people design for developing countries, they think poor people are okay with something which kind of has to be hacked together and made in some very small little workshop, which is going to fall apart because they're going to do all the maintenance. But that's not the case. If it's a business tool, which these are, it has to be high quality engineering and design. And spare parts have to be locally available, right? So you have to use the private sector to sell your spare parts and your products. So that's great. So here we are, and we're saying we're going to set up businesses that millions of people can start with a very small investment and be very profitable. What kind of businesses could they be? Well, the first question with any business is simple, is who are your customers? Right? Because if you don't have customers, you don't have a business. So if you're poor, well, you don't know many wealthy people. You certainly don't know any Americans. So who are your customers? Your customers are going to be other poor people, right? So you better be selling to your other poor people. Right? So what do poor people buy? Well, we just made a list before of what poor people buy, what they spend money on. So we have that same list, so you better be selling them one of those things or you don't have a business, right? So that's what you got to be doing. And, so that's great, but it shouldn't be that difficult. Why? Because the poor everywhere in the world pay the highest price per unit for the worst quality goods and services. Okay, the poor in Africa buy cooking oil by the tablespoon. It's all they can afford. It's the most expensive cooking oil in the world, right? They buy electricity by the dry cell battery, the most expensive per unit in the world, right? They buy water by the jerry can, the most expensive in the world, and poor quality too. Even the rent in the slums in Nairobi, right, is the most expensive rent in Nairobi per square foot. They only rent 10 square feet to sleep in, right? But it's the most expensive. And on top of that, the poor get paid very little for their own products and services, and they're very cash flow constrained. So if you think about businesses with these kind of conditions, what do we have? We have businesses that seriously, seriously need disrupting. And if we think about the new disruptive businesses nowadays, this is precisely the kind of situation they're looking for, right? Where people get bad service. Let's take Uber. People are getting bad service with taxis, so you invent Uber to allow millions of people to now pick up and service that job. And there goes my microphone. Okay. So that's great. So that's what we needed to do. Very nice, but we didn't have any money. That was a bit of a problem. And this was 92, 93. Now, it just about happened that one of the things that we'd been working on at ActionAid was a very low-cost pit latrine design. It's a pit latrine slab, usually which has to have a lot of reinforcing in it to go over a hole in the ground. But here we managed to make one with no reinforcing, a domed concrete slab. And it just so happened at that time, there were about 350,000 Somali refugees pouring over the border into northern Kenya, into what are now the huge refugee camps that we hear about and read about all over the news, right? And that's when the camps were first built. Now, when you build a refugee camp, you need a lot of things. You need to feed people, you need to get water for people, you need shelter, and you need toilets. And the Somalis were unique in that they refused to use communal toilets. Usually when you have a refugee camp, you put in communal toilets, and you don't need that many for the people, right? But the Somalis, many of them being pastoralists, had a very good, basic law that you don't go to the toilet where someone else has been to the toilet, so they couldn't get away with communal toilets. They weren't going to use them, and the whole desert was now turning into a sewer. And so our technology suddenly became something that sounded pretty interesting, and we went out in the desert, and this is what it looked like up there. And we set up production units training Somali refugees to mass produce individual family toilets that look like this, with basically these dome slabs. You put them on the side there, and we mass produced these things. We ended up doing over 100,000 pit latrines, probably the world's biggest pit latrine project ever, in refugee camps in northern Kenya, and trained all the other camps to do these pit latrines as well. And for us, of course, we needed to make the money from this because it was a UN contract, and we managed to skim a bit off the top to match our British funding, which enabled us to do what we actually wanted to do, which was develop technologies for, not for relief, but for development. So back to what kind of businesses can the poor start? Well, the first one we started with this machine here, which is for making very strong building blocks out of soil and cement. Take soil, put a little bit of cement in it, and compress. Otherwise, your choices for building are mud and wattle walls with sticks and mud, or you can go to a concrete block or stone blocks, which are very expensive. This made a very nice intermediate, very low-cost block. This particular entrepreneur here, he started making these blocks. Today, he owns a bunch of shopping malls. Turns out it's a very good technology. I created with a couple friends a private company called Makega to mass produce these machines. They've sold tens of thousands of these machines, millions of buildings across Africa made with these blocks now. So that's the first thing we did. Another technology was, I mentioned the very high price people pay for cooking oil, was a machine for making cooking oil, low-cost cooking oil in the rural area. Now, if you're a farmer and you grow sunflower seed, you can't process it yourself, so you sell it to a middleman who sells it to the factory, who processes it, who brands it, who packages it, who sells it back to a middleman, who sells it back to you at a very high price, and this needs disrupting. If you, on the other hand, could process your sunflower seed in the rural area, you could buy it from your neighbors, give them a higher price than the middleman is giving them, because you don't have all those markups, and sell them oil cheaper. And so we had a machine for making cooking oil out of sunflower seed. Very profitable business too. We sold thousands of those. You also get the animal feed as a nice byproduct. And then a machine for baling hay. It turns out that baling hay is a great business in East Africa, because if you have a farm, you want to keep a cow so you can milk your cow. If you let that cow graze, guess what? It eats all your crops in the crop season. So you have to keep it in a cage. And then you have to buy fodder to feed it. And in the dry season, you have to buy hay. And hay has to be baled, otherwise it rots, in order to transport it. And I just got back from Kenya last week, and right now in the dry season, one bale of hay is selling for $5 on the side of the road, because the only people who can bale it are the big companies that have the huge balers. So again, if you have a human-powered baling machine, you can do 80 bales a day. Well, 80 times 5 is not a bad income. This machine was retailing for about $1,500. But you make it back pretty quickly, in just a few days. Anyway, so that sold hundreds of those machines too. And we said, great, so we can create tens of thousands of jobs, businesses, but we need to create millions. What business can millions of people in Africa start that's going to be very profitable? What is that business, right? Well, it turns out that 40% of the people in the world and 80% of the poor in Africa are one thing, and that is smallholder rural farmers. And they're struggling on small plots of land with very primitive tools just to make a living with their machete and their handheld hoe. And so what business can they start, right, to make a lot of money? Well, it turns out that in sub-Saharan Africa, by far the best way for millions of farmers to start a business and make a lot more money is one simple thing. And that is to move from rain-fed farming to irrigated farming. And the reason for this is right now, they all plant at the same time when the rains come. They all harvest at the same time. They can't sell to their neighbors. That's their market. They're other poor people. They can't sell to them because they have a crop too. So they're stuck selling to middlemen, get very low prices because everybody's trying to sell at the same time. And in fact, not only that, flooded markets, low prices, but 45% of the produce they grow in the rainy season rots before it's eaten or sold, which is a tragedy in a place where people are hungry, because 3, 4, 5 months later, there's no food. And they call it the hunger season, the dry season. With irrigation, on the other hand, year-round high prices at the farm gate, because you're the only person in the game. And just to show this a little bit more clearly, if this is a typical place in Zambia where you have one rainy season, or many places in Africa, you got the months going out across there, you got the rains shown there, starting to rain. So you plant your rain-fed crops sometime there. And then we got your rain-fed harvest. Well, you start by harvesting the vegetables and legumes right after the rains. You make a bit of money there. And then you go into a hungry season with no food. And then you get your maize harvest. And again, you got some money, you got some food. But there's a hungry season there, and guess what? There's another hungry season now coming up to the next rains, right? If you irrigate, you can fill in those hungry seasons right there, get the high prices, grow throughout the year, and multiple harvests, many buyers, highest prices, no waste. And nowadays, of course, with climate change, and Africa's getting hit very hard with climate change, it's even more important, even to save your rain-fed crops, irrigation is critical. So with irrigation, you get 2.5 times your yield because you grow multiple cycles per year compared to rain-fed, but you get about 4 times your income compared to rain-fed. Now, if you combine that with better seeds and fertilizer as well, you can actually get 10 times your income compared to what you were doing with poor seeds and fertilizer or no seeds and fertilizer, just the normal traditional way of farming without irrigation. So irrigation is hugely profitable. Like I say, multiple harvests, higher prices, higher value. So 20% of farmland globally is irrigated, producing 40% of our food. Okay? 35% is already irrigated in India. 40% is already irrigated across Asia. But in sub-Saharan Africa, only 4% of the farmland is irrigated, and this is precisely why it's so profitable, right? Because nobody else is growing any food. And of that, 65% of that is in Sudan, South Africa, and Madagascar, and 40% of it is large farms. So the amount done by smallholders is tiny, right? So how do we tackle this problem? Well, if a farmer wants to irrigate, what do they need? They need a pump in order to get the in order to get the water out of a well and to the field. And they have a choice. They can use a bucket to pull it up and walk and do that. Or they could try to get a petrol pump, which is a bit expensive, but very expensive to maintain and use because you got to buy petrol every day, and in the rural areas there isn't any petrol and you can't store it when you get it. And then when it breaks down, you don't have spare parts. So this is why we designed these human-powered pumps. This is a pump I'll show you in a second. We originally, starting in 1999, called the Super Moneymaker Max, a little Stairmaster machine. And our brand is Moneymaker. Why? Because people care about making money. So that's our brand. It was either that or sex. But so it's efficient hosepipe irrigation, where you actually take a hosepipe to the field and put it right onto the plants, just like you would with a garden hosepipe. So you have very efficient use of water, right? And it's now morphed into this pump here, which is the Moneymaker Max, little Stairmaster machine. Just walk back and forth like this. You have a hose pipe here going down into the well, a hose pipe there going off into the field. You can put sprinklers on it, but you don't need it. It's just a pressurized hose pipe irrigation. So this nice little pump here gives you some good exercise, but it can irrigate 2 acres of land if you work a couple hours in the morning, a couple hours in the evening, which is when you want to irrigate. And with the hose pipes, it retails at $160. That's with all the markups and the hose pipes and everything for a farmer. So that's a lot of money, but we've sold a lot of those. But it's a little bit too much money, so we said, let's design a cheaper pump. So we designed this pump here. So this looks like a bicycle pump. And sure enough, if you get on it here and you do this, your arms get tired very, very quickly. I think they're already tired. But if you operate like this, because it's got a pivot, you can do this all day. So just by simply changing the ergonomics, you can make a pump that operates all day. Again, it sucks water from as deep, both these pumps, from as deep as 7 meters deep, almost 30 feet deep, and then pressurizes it another 7 or 8 meters vertically. So you've got 200 meters along flat ground or up a hill. And so with that rocking motion there, this pump retails, including the hose pipes, and hose pipes are expensive, for about $90. Irrigates about 1 1/4 acres. I'm just going to tell you one story about a woman who got one of these pumps over here. So this is a woman who was telling me, she lives in Western Kenya. She lived on a 2-acre plot. She told me this story. She told me 8 years ago, my husband died. He was living in Nairobi. He was sending us a bit of money every month. And I was left with these 2 young teenage kids. And I had absolutely no income. And I was on this 2-acre plot. And I went to my father-in-law and I begged him to help me. And he said, look, I'd like to help you. I'm also a poor farmer. Really not much I can do to help you. But I've seen this Moneymaker pump. Let me see if I can try to save for one. And the father did. He saved up, sold a goat, managed to get her a pump. Gave her a pump. And immediately she had the 2 kids working on the pump, but then she quickly realized she could actually send the kids back to school. She hired a young man to work on the pump with her. She irrigated the full 2 acres, was growing kales and cabbages and tomatoes. And then she told me 2 years later she had enough money to buy a couple dairy cows and open a dairy. After another 2 years, she had enough money to open a poultry farm. In the 5th year, she had enough money to buy another plot of land next door and start irrigating that. And then she told me, today, my daughter is at university in Denmark. My son is in a top private school in Nairobi, and all of the fees come from my farm here. So there's a lot of money to be made if you can grow. So very stringent design criteria, of course. And by the way, that woman on the right there with me is Krista Donaldson, who was also a Stanford PhD, came out and worked with us for a while and then started now is the head of DREV, another social enterprise. So design criteria, these things have to be extremely strong and durable. They're miles off the road. They have to be really easy to repair. You don't need any tools. The farmer doesn't own a screwdriver, doesn't own a hammer. You don't need any tools to take these apart and put them back together. And no training. Training is expensive and hard to do. It has to be intuitive to use, easy to transport and store. And it's manually operated. A human can put out about 80 watts continuous, not very much. Yeah, and if you get on in the gym, you can maybe do a few hundred if you're a top athlete, but you know, about 80 watts. So you have to be really ergonomically and hydrodynamically efficient when you design these pumps. So they look simple, but there's a lot of engineering that goes into these things. And then there's cultural issues. You know, you might ask, why are these pumps stepped down here? Isn't that very expensive to make it step down here? Well, the original pumps, of course, weren't stepped down there, but then we found that women refused to use them. And why was that? Because now their hips are dancing at eye level. And we discovered that, had to lower down the pumps. And now every pump made in Africa by us and all the copycats have that same step down there. We train large manufacturers to produce these pumps. Initially, we did that in Kenya, but now we actually do it in China. It turns out it's cheaper and cheaper to ship from China to Africa than from Africa to Africa. Depressing news, but true. So we manufacture in China. We establish a private sector supply chain. We contract the manufacturers. We do the warehousing, the bundle, and distribute the pumps, and we sell to local retail shops. Everybody makes a margin, so at least in theory, it's sustainable. We had about 300 Agrovet retail shops in Kenya, Tanzania, and then Mali. We went to West Africa, every city, town, and village. And it sounds good, you know, you've got a great product, you got a good distribution. How come it's not just taking off and jumping off the shelf? You know, this is a great product, people buy it, they're going to make a lot of money. But it turns out that, you know, this really is the most challenging marketing and sales job in the world. And even Coca-Cola, which is selling an addictive sweet drink, took probably over 10 years, it seems, to start making any kind of profits in Africa, and they spent hundreds of millions in marketing to get there, right? And why is this? Well, because we're taking the poorest, the most risk-averse, and the hardest to reach customers in the world who live, you know, miles and miles off the road, and we're selling them a brand new big-ticket item they've never seen before, and much more than that, we're asking them to change generations of farming practice. Right? It's a huge change from rain-fed farming, where you wait for the rain and you plant, you wait for the harvest, you harvest, to get up every day and irrigate. It's a huge behavior change. And on top of that, it turns out there's limited word of mouth. You'd think word of mouth would be very quick about making money, but it's not. Because if you live in a very poor community and you make some money, guess what? All your relatives, all your friends come, hey, you made some money, I've got a sick kid, hey. So if you talk about how much money you made, that money disappears. So there's very little word of mouth about making a lot of money. And that was one of the lessons we had there. So we use our donor funds, because we're a nonprofit, to do major educational and promotional campaigns. We have branded stores. We have, at that time, we had hundreds of commissioned sales staff out there training the farmers, talking to them, radio, mobile, promotions, billboards, and a lot of demos, on-farm training. People have to see it to believe it. We had a lot of partnerships with the government, with NGO, with businesses. And because we're using donor funds, we had to measure the impacts. We did a lot of internal studies to measure them and also external studies. So how do you measure the impact of something which you've sold to somebody in a retail shop and they've taken it away? So we had to solve that. We had a guarantee form. Every one of these pumps came with a guarantee. The farmer filled out the guarantee form. Now we had a detailed information about that farmer. We could track that farmer down. We could visit them within the first month of when they bought, after 18 months, after 36 months, and really track the progress of how much money they made with randomized surveys. So what was the result of that? Well, on average, these farmers in East Africa, when they use this pump, within the first year, increasing their net farm income by $700, which is a huge increase. But even more significantly than the amount of increase is that it is now spread out into that dry season where otherwise they fall into poverty, right? Because if you're a rain-fed farmer, you get your harvest, you make a bit of money, and then you fall into poverty. And then somewhere here the rains come again, you don't have any money for seeds and fertilizer. So your next harvest isn't going to be too good either. But now with irrigation, as we saw, you're making your money there. and you no longer fall into poverty, you make other investments. So we talk about taking families out of poverty. How do we think about that? They have food security and income security throughout the year. They're never worried about how to feed their kids. They have enough money for the basics. They can send their kids to school. Got a few 100,000 kids in school for the first time. But more importantly, on top of all that, they have some money left over to plan for the future. And if we think about that, you're no longer worried about survival. You can plan for your future. That's really a nice sort of thought about how to be out of poverty. So what do? They make other investments. They build houses. They start new businesses, more education, better life. With a 400% increase in net farm income, we're really trying to build this entrepreneurial middle class of successful businesses. And of course, successful family farms is in many ways what America was built on too, but they're not successful in Africa. So we worked hard at all this, and by 2015, we looked at what we'd done. We'd sold 270,000 pumps. Not every pump creates a business, but 200,000 families were doing very well. 180,000 local jobs, paid jobs, $170 million a year, new profits and wages, 1 million people taken out of poverty, and 10 million people fed with all the fruits and vegetables they need. So that was in 2015, and just to illustrate that with some real people, there's 1 million people out of poverty. But one person every 7 minutes taken out of poverty, and a new person getting fed with fruits and vegetables as a result every minute. So that sounds good, but it's really just a drop in the bucket. There's huge potential impacts from small-scale irrigation across Africa, right? Like I said, only 4% of the farmland is irrigated. You got these different climate zones here. You got the rain pattern here, and of course, you don't want to irrigate where it rains all the time, and this is showing the places where you get seasonal rain, and obviously if it never rains, you probably can't irrigate. This is rural poverty. This is the groundwater availability. There's a huge amount of untapped groundwater in sub-Saharan Africa. We're using less than 10% of our renewable groundwater water sources, as opposed to California, where we probably use about 150%. That's the sort of areas of high potential for irrigation on rural poverty. But for Africa to feed itself, we have to get close to the global average of 20% of the land irrigated. Wow. Okay. So we need to massively scale. So I've just been told I have very little time left, but I might stretch that a little bit. So we put together a new strategic plan to scale, and we want to enable another 1 million people to climb out of poverty by 2021. But to do that, we have to work differently. What we realized is that doing retail sales, our staff getting out there, meeting farmers, convincing them to buy a pump was an extremely expensive way to sell a pump. And that's why we could never be anywhere close to profitable, why we had to use donor funds to do all that education, because we're looking for a huge behavior change. So instead, we've gone to a leveraged partnership model where we now work with organizations that are already working with thousands of farmers on the ground. We convince them that they should introduce pumps into their programs, to their farmers. And it's highly leveraged, and in that way, we spend our effort now working with the partners who then talk to the farmers instead of us spending a lot of effort down working with the farmers. To do this, we had to completely swap out our sales team. Those distributors, by the way, will also sell to retail shops. And we had to teach a whole new way of selling to our sales team, because you're no longer doing one-on-one retail sales, convincing a farmer to buy a pump. You're now going and talking to an organization about how you can help them solve their problems by having them introduce the right pumps and irrigation to their farmers. We said, let's work in the 16 highest potential countries across Africa. So we're working out of 3 hubs in West Africa, East Africa, and Southern Africa with these 16 countries. And like I said, we partner now with every type of NGO, with government organizations, with private sector organizations in these countries. We teach them about irrigation, we train them, we do training of trainers, we do training of their farmers, and it's very high leverage with a very low marginal cost. And then, at the same time, we need to have a private sector supply chain. So we work with the biggest importers and distributors in these countries so that the pumps and the spare parts are locally available where we sell the pumps. So we're going to take another 1 million people out of poverty by 2021. That sounds good, but guess what? how many people, new people, you think Africa is going to have by 2021? Any guesses? How many? 100 million at least. 200 million. Right? So we can take 1 million out of poverty. Africa's growing by 200 million. We're not really moving forward. So actually, we need to get beyond just being a social enterprise, doing our own selling and selling. We need to think much bigger. Okay? And so we need to develop the right solutions. We asked ourselves, what would it take to get Africa to 20% irrigated? What would it take to get there, right? And it's really 3 things it's going to take. Yes, we need the right set of technologies. Okay, we need the right set of tools and equipment, and we've got part of that solution, but there's other ones we need in terms of accessing and storing water, pumping water, distributing water to the crops. We need that. We also need the right methods of doing that behavior change, the right ways of enabling farmers to finance and purchase their products. So behavior change, financing, distribution and training, we need those right methodologies. And finally, we need the participation of all the other players, of all the major stakeholders. We need to get the UN, we need to get the major donors, we need to get the African governments, we need to get the African Union, we need to get all the NGOs understand that irrigation could have a big potential. It turns out that irrigation is completely off the agenda of these organizations. I go to major agricultural conferences for agriculture in Africa, not a single session, not a single mention of irrigation. Irrigation's got a very bad reputation with environmentalists because in California, rightly so, we're using all our water and it does a lot of damage. But if we can leapfrog the bad part of irrigation, we can leapfrog flood irrigation and channel irrigation directly to pressurized drip and sprinkler irrigation, we can get beyond those things. But we need to have a campaign to irrigate Africa. So this is what we're doing with our new plan. We need to change the system. We're setting up an innovations hub, and we need massive collaboration and participation. So we're already doing some interesting things here with financing. We're partnering with a whole bunch of microfinance organizations developing new methods and new products for financing irrigation. We're doing agripreneurship training, targeting the youth with organizations that work with youth, organizations that work with women. We're doing a very interesting study with UCSF Medical School targeting families that are HIV positive out in Western Kenya, seeing what impact an irrigation pump has on those families. And in the initial trial, amazing impact, drop in viral load of 45%, increase in CD4 counts about 35%, because these families now have enough food so that the drugs start to work and have enough money and huge mental health impacts. But we need to partner, and we are. And new products. I just want to finish this back on engineering, even though, as you can see, as a social entrepreneur, you spend a lot of time doing stuff which is not engineering. But I do just want to jump back into engineering at the end here. New products. We need a lower cost pump, $90, too much money. Can we make a $45 pump that has pretty much half the price, 3/4 of the water output, something we call a starter pump? Well, obviously you have to save material, and you need lower cost manufacturing. We have to move from metal to plastic for our valve box, smaller hose pipes, but smaller hose pipes mean more friction, therefore you need much more pump efficiency in your design. So you have to design a valve box which is very efficient. So we use fused CFD analysis using Autodesk's Fusion 360 and Inventor, thanks to Autodesk, who has donated that to us. Of course, like any design, you come up with your concepts. Down at the bottom, you can see we're here looking at what is the fluid dynamic friction out of these models. And we can see that it's going down over time as we get better and better at designing these things till we get it down to 1.75 atmosphere, which still sounds like a lot, but these are done at very high velocity. So we now can design the lowest friction hip pump and have a final design that meets all our design criteria that we wanted. So that's great. So certainly human power pumping is going to be a big part of the solution still going forward, because so many places, like I say, petrol is still hard to get. Maintenance is hard to get. And this little pump, I'm just going to tell you one more quick story about this little pump. The one I just showed you, this one here. One of the things you do when you're designing a new product is you do field testing. Of course, you do the design first, and you do field testing, then you do market testing. So about a year ago, we decided to field test this new little pump. And we went out and we met this guy, James. And James had been working in a coffee factory. He lives just about 20 miles north of Nairobi. He'd been working in a coffee factory, making $50 a month. Could barely feed his kids. He quit that. He rented a little tiny plot of land about the size of this room next to a little stream. And him and his wife got out there with buckets and started irrigating that, growing a few kales and spinach on there. And he got his income up to about $80, $90 a month. We gave him one of these pumps. I went out to visit him 6 months later. He'd rented an acre of land. At that time, he was irrigating 3/4 of the acre. He was growing kales. He was growing spinach. He employed 2 people full-time. He was making $10 profit per day. I went back to see him on my last trip just now, a year later from when he started. He'd taken that other 1/4 acre. He's growing tomatoes. He's making $20 profit per day. He employs 4 people full-time. He's just rented another acre of land downstream. His kids are all in school for the first time. His wife has now started another business because she's no longer hauling buckets of water with him. And the transformation continues. But like I say, human-powered pumps aren't the only solution. What about a solar pump? Obviously, that's going to be part of the solution. Can we design the world's most efficient, lowest cost solar irrigation pump? So we set ourselves some tough design criteria: flat pack, portable, plug and play, flexible design, has to fit into a tube well. It also has to fit into a muddy puddle and work just as well because you don't know where they're irrigating from. Has to have a maximum efficiency at 7 meters head with only a 90-watt panel, so it's portable, so you can carry it. Irrigate half an acre of land and retail for $150 in Africa, including the hose pipes. Right? Is that possible? And also have extra features so you can charge your cell phone and other things. Is it possible? So first of all, we looked on the market. We tested a lot of pumps on the market. We saw, tested their efficiency, tested their flow rates. And really, there was nothing close to this in the price range, nothing close to it in the performance range. So we said, okay, so how are we going to design this pump? Now, we're sitting in Africa. We're pretty good at mechanical pumps, human-powered pumps. How are we going to design the world's lowest cost solar pump? So we said, okay, we have to partner. Who are we going to partner with? So find the best collaborators. So we identified a company called NCAP. So NCAP are basically the inventors of the encapsulated pumps and of brushless DC encapsulated motors. They're the world's biggest manufacturer of brushless DC motors for the automobile industry and of encapsulated pumps for the automobile industry. Every car that we drive today has about 10 or 15 brushless DC motors and 3 or 4 pumps. And what NCAP has done, Tesla uses their technology, everybody uses their technology who's making brushless DC motors, is they have found a way to encapsulate a pump with a motor in a single molding process, so you can get a pump which is $5 to $10 for the pump itself. So radically reducing the cost. So we're working with them to design this pump. And you put 90 watts of panels on there, and you start to understand how you can get down to that kind of price range. So we're confident we can do that. We've made good progress. And then we said, okay, we also, $150, which is about the price of this, is still expensive. Can you do a pay-as-you-go system so that people only pay for the pump when they use it? So this is being used a lot in lighting systems, solar lighting systems in developing countries. You give somebody a lighting system for their house, but it doesn't work. They then have to pay you, usually using their cell phone, to transfer the money to you if they want to turn on the lights for 1 week. So they pay you for a week. You send them a code with a text. They punch that text code into a little panel on their lighting system, and their lights go on for a week. Then the lights go off. Then they have to pay for the next week. So it's pay as you go. After a year, they own the lighting system. Can you do the same thing with an irrigation pump? Because with lighting systems, that's really taking off. So anyway, that's what we're looking at. So to that, we're going to develop and test that. We're working with a company called Angaza, who have this kind of system with an embedded PAYG system with a back end. So this is a company working in 8 countries, but it's a startup out of San Francisco. So we're working with them. And that's great. We can develop this, but then how are we going to scale it? Is Kickstart going to build a big company to scale pay-as-you-go solar pumps? No, we're going to work with organizations, companies that are already out there scaling pay-as-you-go lighting. They can add pumps on as an additional product. So some of the biggest companies are these. We're already in discussions with them. So again, massive collaboration in order to scale. So the other thing we had to do to get a really low-cost pump is we had to come up with a new patent. We've developed quite a number of patents, but this particular patent is for a modular pump concept. And it turns out that if you're trying to pump water, you have a pump that pumps at 7 meters and you want to pump to 14 meters, if you put 2 in series, they can pump to 14 meters. You put 3 in series, they can pump to 21 meters. Okay, but what we did is we patented that concept with a snap-together pump. So double the head, you snap 2 of the basic units together. Double the volume, you snap them together sideways. Triple, or you want to get double the head, double the volume, you snap 4 together. So you can have a very cheap basic unit, which is then produced in much larger quantities, of course. So this is what we're going to have with this. Of course, you want a very lightweight folding tracking solar panel. You want to have a concept for carrying it to the field, because a farmer can't leave a solar panel in the field. They've got to carry it to the field with them every day. Backpack. We've already made some great progress with this team, with the design team now, on this new solar pump. And we're hoping to have prototypes out in July and a year from now launch this. So that was getting back to why engineering is so important to make this all possible. But it's, like I said, it's actually much, much more than just engineering. And that's all I'm going to say. But engineering, partnering, innovating to irrigate Africa, lift millions more out of poverty. And thanks a lot, guys.
Thank you for a great, inspiring presentation. I think we have time for maybe a few questions. Yeah.
So, Martin, I followed Kickstart from the early days and supported you from the early days. I think it's a fantastic operation. And I recommend it to everybody that I know that's looking for a nonprofit that's going to really have an effect. One question I have for you is, in the model that you proposed, the new model for marketing and sales, it seems like you had a lot of nonprofits that you're working with. And my question is, I don't think that nonprofits typically understand entrepreneurship or business. Is it going to be a problem getting them to understand this and also eliminating the bureaucracy that a lot of those organizations have?
Yeah, well, first of all, thank you very much for your support. Yeah, so this was a difficult decision for me to make because, of course, we worked in one of those big nonprofits. We saw all the things that don't work so well, and we jumped off and said, no, we have to be a social enterprise. No, we have to work independently doing direct sales to farmers. And we did that, and we got 1 million people out of poverty. But looking back at what we had done, it was very expensive. Our cost of getting to these customers was very high. And the truth is that since we did this work way back in the 80s to today, even many of the very biggest nonprofits have really moved in the needle in terms of turning away from direct handouts, turning more to at least having the farmers have some skin in the game, whether it's a full loan or a partial loan. And as an example of that, if you look at World Vision, which is famous for handouts, they spun off Vision Fund, which is a for-profit microfinance bank. And now Vision Fund is working with World Vision. Anytime they have a product they want to hand out, they're now giving credit for it instead. So it is a bit of a dilemma because you're trying to go to massive scale. But to get to massive scale, you do have to make some compromises because I think otherwise we could be heads down, plowing our own farrow, and sticking too much to our commitments and actually missing a big opportunity to scale. And the truth is, when it comes to farming and irrigation anywhere around the world, there have been and are today large subsidies involved. And you just have to make those subsidies very, very smart. And what we're being able to do now is having really detailed discussions with these nonprofit, with the leaders, and have them understand a lot of this as we work with them. But thanks.
All of this technology relates to moving water from a source. Now, what about the technology of sourcing, drilling the wells, stream efficiencies and all? I mean, Is there infinite water? What are the problems there?
No, so obviously that's a very good question. How do people actually get the water? Now, there's not even good maps of water availability across Africa, and certainly aquifers change, one location to another. You can have a shallow aquifer here, and literally we go 30, 40 meters, it can be a deep aquifer. So that is an issue. How do you map the water? How do farmers actually get the water? But our guesstimates are that somewhere between 30 and 40% of all farmers in Africa actually have access to shallow groundwater right on their farms. And that's not because 30 or 40% of the land has access to shallow groundwater, because why it is because people throughout history have always settled in concentration in those areas where there is access to shallow water. So those farmers, that 30%, can literally dig a hole in their own plot and get water right there. And usually if it's only 10 or 15 feet deep, they dig it themselves. If it's deeper than that, they get a local well digger, and every one of these communities has well diggers. And those guys will go down even 100 feet, 150 feet with just hand digging tools. And the nice thing about digging a well is you don't have to pay for it all at once. You can pay for it over time. You can have somebody dig 10 feet today, come back a year later, dig another 10 feet. So it's a layaway product, which makes it more affordable. But certainly drilling for water is also something that has to be done. We've developed a very, very low-cost hand auger, the lowest cost well drilling technology in the world. Literally, it's a hand auger. And as long as you don't hit any hard rock, you can go down 30, 40 feet in about an hour. And then it's only 1.5 inches in diameter. You can put a hose pipe down there. You can clean out the aquifer with a suction pump and now start pumping from that. But it only works in places where you don't have hard rock. Other people are working on hand augers that go through even harder rock, but it's still a challenge, and we need more technology on it. Yeah.
Have you considered that obviously those are all manufactured, but have you considered local products or recycled products in building things? Like, instead of those things, coffee cans or something that they have there, it's going to be recycled or locally.
Yeah, so we started off manufacturing locally. We started off manufacturing in very small workshops locally. And then we realized that you couldn't get any economies of scale. So we went to bigger workshops. And then as the sales picked up, we realized you couldn't get the quality you needed. We went to the biggest factories. We taught the biggest factories in Kenya to do high quality mass production, the first time they'd ever done it. We had to develop whole new methods of production because the raw materials were so bad. So you get a standard 2-inch by 1-inch hollow section like this material here. And what you get in Africa is plus or minus, 4 or 5 or 6% in each dimension. So you can't do mass production very easily with it. We figured out how to do that. I probably spent 15 years of my life proving you could do high quality mass production locally in Africa, but we still could not compete with doing it in China. There's a number of reasons for that. Partly that skilled labor in China is unlimited, while in Africa we had to train it. And then, you train labor, and then they're the best, and then they want more money, and that's understandable, but then we have to train more. And then shipping also is a big issue. Shipping from Africa to Africa, like I said, is more expensive than from China to Africa. But I think this really, your question also gets a little back to my first point there, is that if you want a business tool, you don't want something that in Kenya we would call jua kali, which is made under the hot sun, which is a little bit what you're suggesting here, is that we take local materials and we recycle them and sort of piece things together. You want something which is going to be a really, really reliable business tool. You can't have this pump breaking down. That woman I described to you, she invests in this pump. It can't be something that she has to then learn how to repair or that breaks down in the field, right? It has to be just like any tool we use. It has to be 100% reliable, even more so because they're taking a big risk with it. So I really moved away from the sort of local made, piece together your own thing with, coffee cans and rubber bands to high quality mass production. I really think has to happen if we're talking about business tools. And just because they happen to be the poorest people in the world, they need the better business tools than we do, precisely because they are the poorest.
Okay, let's take just one more question.
You didn't say anything about wind, and I'm from Argentina. You see a lot of wind pumps there. What is the problem with that?
Yeah, so windmills are certainly part of a solution. They're expensive. You have to build a structure. You have to have long pipes coming down from them. You have to have long rods coming down. So they're expensive. but there's certainly a place for windmills, mainly for communal water. And so people use them in Africa for watering herds of animals, for example, cows. But for an individual farmer, I think it's generally too expensive a solution for individuals. Let me take the other question in the back.
Yeah, I'm curious about how you decided to patent your technology instead of making it open source.
Yeah, so that's a very good question. And there's a big dilemma. I mean, because we can patent stuff. The question is, why did we decide to patent our technologies instead of making them open source? And it's a good question. I think it's a big dilemma about what you do with patents or not patents, especially with physical technologies. If you want to have a business model where you're actually making money, you don't want everybody copying your product. On the other hand, of course, people are going to copy them, even if we do patent them, and we do patent them. So, for example, this machine is patented in a few places. We actually let the patent drop in India. And now there's a company in India that's photocopied this and basically making an almost identical pump, but it doesn't work as well. A lot of other people have copied our earlier products and made pumps which are cheaper, but don't work at all. And so they've actually killed the market. And what they've done is they've sort of followed us around, and they'll go and apply for tenders, and they'll pay a kickback, a bribe, in order to win the tender. And they'll also have a lower price, and they're putting a lot of product out there on the field which doesn't work. And to me, that's extremely irresponsible. You're risking taking the lives of extremely poor people who are investing in this products, or even if they get it for free, they're investing their time and energy into planting, and then they end up with bad, poor quality products. So the primary reason we patent is to ensure that in the early stages of a new product introduced to the new market, that there's some way we can try to maintain that quality. But the truth is these patents are almost impossible to enforce, and especially in Africa, but even in many parts of the world. So we've never actually tried to enforce the patent. But at least we're in a position where if there's, for example, a large nonprofit which is thinking about buying a knockoff product which we know isn't going to work, we can go to them and we can say, look, get the thing that works. And if you're worried about that, we can actually show you that these guys broke a patent. But that's the main reason that we want to do it.
All right. Well, please join me in thanking Martin for a great presentation.
Thank you.
Thank you again for being an inspirational hero. And I'd like to thank all of you for attending, and we are going to invite you to join us in a reception right outside this auditorium in the lobby. Thank you.
Great, and I'm happy to talk to anybody there. Thanks so much, everyone.